Yeah, we've got a Delonghi DEM10 dehumidifier. This one. Faulty spares or repairs on eBay, bought for 99p, picked up locally, and yeah, the guy says it doesn't produce any water, and I've got it plugged in over here, and if I just turn it on, yeah, I can hear the fan running. The actual fan motor, that's the cooling fan's working, but the compressor's not working. No. So it's just not working. As he said, it's pretty much dead. There's not even any lights on really, it's flickering. No, not doing very much. Okay, so yeah, it is faulty, so let's take it apart and see what we can find, shall we? Okay, I'll just show you to take it apart. It's pretty simple really. You just pull the drawer out, the main drawer. That's the water tank basically. Pull out the filter. Now if we just turn our attention to the top here where the handle is, you can see there are two screws, one there and one there, which you take those two screws out, if I can find a screwdriver. Put them somewhere safe. Then you grab hold of this part and just pull. I'll do this single-handedly. I don't know if I can. I can pull that forward. Yeah, you can see it's all full of fluff in there. Look at that. It's a fluffy thing. And if you look down behind there, you can see behind the handle there is two screws. So to get the handle out, you have to take this part. Come on. Don't mess me about. And in there, pull that edge forward. If I just get the handles coming out. There we go, that's one side. So if I can do it single-handedly, you can do it with two hands. Then you whip these two screws out here. There's one just there behind the handle. Another one. It's like my motorbike I'm building. Okay, and then looking around here, I'll just show you the other screws. I won't take them out on camera. Oh, remove the drain plug. This is for the continuous drain, if you don't want to use the water tank. Over there. And you can see there's two screws. There's one screw here in the back next to the water plug. Another screw there. And there are just two more, I think, somewhere. Yeah, there's two. There's one down on the bottom edge. You can see there's a screw in there. And then if we go around to the other side, there's a screw in there as well, down the bottom. And I think that's all the screws there are. It's pretty easy to take apart, so I'm just going to take those screws out and I'll be back. Yeah, and the screws, there we are. So and the case just comes off. Let's have a look inside her. So there's the controller down there, there's the compressor in the base. There's the heat exchanger and the cooling fan. Very, very dusty in there. Nice bearings on there, look, running beautifully, so the fan's not a problem. And yeah, just the pipe work and everything else. So if we just, there's nothing this can short on, so we can just plug her in and see what she does. According to the guy that sold it to me, it doesn't cool at all. It just doesn't work. So let's just turn it on, see what happens. Nothing at all, because we haven't got the water tank fitted, have we? Just put the water tank in, turn it around carefully. The water tank has got a safety switch, so it cuts the power when the water tank is not fitted. So if we just slot that in there, it might turn it off, reset it. And there we go, it's come back to life. So that's blowing dust out at me. So there you go, you've got the fan running, compressor is dead. So if you have a look around here, we've got, this is just, I think, a rheostat type arrangement. I don't think there's a moisture sensor in this. I think I'm right in saying it just turns on and off to regulate the actual cooling. If you think about it, I'm fairly sure there isn't a moisture sensor, i.e. a humidity sensor in these things. I'm not entirely sure, but I will check that. So here we've got the controller down the side. I guess the main thing to check is to see if there is any voltage on the I've got the camera down here on these connections. We'll just see if we've got any AC mains coming into the compressor. Goes without saying, be careful. Alright, so if we poke that one down on that connection and poke that one onto there. Okay, there's no power coming to the compressor, okay, so clearly the fuse is alright, but the compressor is not being switched on. So we've probably got a controller fault, I should think. It is a pretty simple thing. If the fan is running, then the compressor should be going when this is turned up, and it's not. Yeah, I'll take the controller out and we'll just check it on the bench. In my experience, rather than poking around and shorting something out, it's worth just looking at the actual controller itself. So she's not running, so let's just go and give the controller a health check on the bench, shall we? Obviously, to take it off, you just remove these screws, make sure it's turned off, remove all the connections, note where they go, take a picture with your phone, and then I'll see you indoors in the lab and we'll have a look at the actual controller itself. Okay, so here's the controller we took out of the dehumidifier. We've got isolated mains coming through, so it's not really live and neutral, it's just 230 volts with no reference to ground because it's linked through the flux of the transformer. There's no copper going back to the main supply, only the coupling through the magnetic field of the transformer. Yeah, I've got 200, let's turn up a bit. There you go, 240 volts. Right, so there's 240 volts coming in. And what have we got here? We've got, this is just a buzz bar, neutral, 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 all just soldered together on the back, as I checked. The live goes through a 20mm glass fuse with a little rubber bungee cover on. The fuse is good because nothing would run because all the power that goes through this thing has to go through the fuse, and we saw the fan was running but the compressor wasn't. Filtering capacitor, just a HF decoupling capacitor from any noise coming back through, although this is not a switch mode power supply, so really that's not strictly necessary. It's to stop any radiated noise coming in through the cable and upsetting the electronics and vice versa. Probably just a stopgap really. Without a switch on a power supply that's not switch mode, there's little noise because it's all baseband stuff. 275, what's that? Varistor, 275 volts to soak up the transients. Is that brown or is that violet? It's browny violet, isn't it? Yeah, that's violet, I think. So that's a 75 ohm resistor. And let's just see what voltage we've got on the ends of that thing. Are we still AC at that point? Got 9 volts at one end AC. .31 volts at the other. So yeah, that resistor's obviously doing something. Is it getting hot? Don't do this if you're plugged into the mains. I've got my feet, I've got shoes on, I'm sitting on a plastic chair. No, that's cold actually. There's nothing going through. Actually, it's a big resistor to actually be staying cold when you think about it. Anyway, so and then the power comes in. I'm digressing slightly. I know I'm getting into diagnostics before I explain the circuitry. Sorry about that. And what we've got here is a 1 microfarad 250 volt AC capacitor. What that is being used as is a reactive voltage dropper. You see it a lot in the older LED lights that didn't have active power supplies in them. They were just simply one of these things. Clearly, if you put a resistor to drop from 230 volts down to whatever this operates, the low voltage DC, even the small current would make a lot of heat in this. If this was a pure resistor, you get a lot of heat there. It would cook away and generally be, as well as very inefficient, produce a lot of heat to get rid of. So you use a capacitor as a reactive impedance to limit the current. So all the power for this board is coupled through the electrostatic field of the capacitor. The current will lead the voltage waveform at 90 degrees through a pure capacitive load, so very poor power factor for this part of the circuitry, but it doesn't really matter because the controller itself is only taking a fraction of the actual power that's being consumed by the whole device, the whole machine. So, you know, a little bit of highly reactive load isn't going to be worst thing in the world, really. So what we've got, anyway, so we've got this dropper, we've got the capacitive dropper, then we've got a resistive dropper as well. Is that connected to the end of the capacitor? Yeah, so the mains comes in through there, to this end of the resistor, and then through some tracking down to these components down here, which is presumably a rectification diode, a filter, and possibly a Zener diode as well. We'll look in a minute if we need to. And we've got a microcontroller here, which is probably a dedicated one-time programming micro. And you can see these relays here, LRDS-S124, 24 volt DC relay. So the coil is 24 volts DC, and they switch 10 amps at 10 amps at 28 volts DC. Are they rated at 250 anywhere? Anybody? Yeah, 7 amps 250, okay. So 250 volt AC, 7 amp relays, and they're just single pole mate to close. There's just 4 connections on the contacts and the relay coil. So if we look on just here, we've got the rectification and the regulation circuitry here, and we've got one there. So that's the microcontroller power. So let's have a look on that back of that capacitor, see if we've got roughly something like 5 volts. Bear in mind this is switched on, so you have to be a bit careful. Keep your mother on speed dial. Where are those connections? Where are you, baby? 4.6 volts, which is a bit low. 4.6 volts across the for the supply. It's a bit on the low side, but it would still probably work. You know, that's sort of within the range of. It won't give the best noise performance or immunity to noise because the switching levels will all be to cock, but 4.6, it's a bit low, isn't it? It is working though, but it's a bit low. So the question is, why wasn't the compressor running? Okay, well, clearly I don't have the control panel plugged in here, so I don't know if it's powered up. But what I would say was that we need 24 volts to run these relays, and neither of the relays are energized at the moment. So if we go between AC 0 volts, which is basically the neutral connection, on our DC voltage range, and we measure on the end of this resistor, which is this end, we've got 8 volts DC. So all you've got is 8 volts, and these are 24 volt relay coils, okay? So either we've got something loading this board, or there's just not enough power getting through, okay? Now if there was a load on this board, this resistor would be getting hot, so all the power goes through the resistor. By measuring across this 75 ohm resistor, we can check to see how much power is being drawn by checking out the voltage. And there is just 100 millivolts across that resistor, which is nothing, okay? So there's not enough power going through. And I think I know what's wrong with this board. These capacitors, I've mentioned this before, so I don't want to be repetitive, but whenever I see one of these caps, if you ever open up a power supply and you see a capacitive dropper capacitor, obviously in a power supply to produce a low voltage DC voltage, then the quality of this has to be a very good capacitor. Feels alright, it's not wobbly or anything. And they break down and they're self-healing, so they're safety capacitors, so that when it blows through the mylar or polyester metallized coatings, it burns some away and heals itself. But they heal themselves away to nothing. So that's the next thing we're going to do is, if you see one of these in a power supply and you're repairing it, it doesn't matter what else is wrong with it, if it's an old device, take that cap out and check it, because without this diagnostic spiel I'm doing now, I would check that anyway, just to make sure that it was the right voltage, because they creep down over time, and eventually, especially things with relays in, you can't get enough juice to actually switch the relay, and it's a very common fault, and it's nearly always this has gone down in value, and it's probably the root cause. So let's just turn things off, turn the soldering iron on, keep on waffling while the soldering iron heats up, because I forgot to turn it on earlier. So all in all, for a 99p unit, this might be a very simple fix. if it is the capacitor. Let's have a look. It should have discharged by now. You can see down in there is a 1 mega ohm resistor. You can see that one in the gap, which is to discharge this. It's sort of intended to stop you getting a tingle off the pins when you unplug it. If you think this is if you switched off at peak cycle, you know, it could have up to well, root 2 times 240, which is 300 volts on there. Well, you can get a tingle from the main socket, you know, if you've got exposed pins. That resistor, as soon as you unplug this, it very quickly discharges the capacitor, so you can't get a tingle off the mains the pins on the plug, on the actual appliance plug itself. Soldering iron is cooking. Should have discharged. It's only a small cap anyway. Let's give me a tingle if it hasn't. That's that one. That's that one. So here we are, look, let's have a look at her. Can you see that? So it's 1 microfarad, 250 volts DC AC, 275 volts AC at a different rating, so it's got 2 ratings. HQX, TX, I don't know what the make, UTX, probably a Korean make. Anyway, without further ado, let's have a look at it. Can you see that? This is the problem with this DM100C. I find it a very good meter, but they've just pimped the display up. If they just used LCD, I'll be able to see it in daylight. If you take it outside on even a sort of a bright overcast day, you just cannot see the. It's a great thing, but the display lets it down. You know, especially with that viewing angle. If I tilt it that way, you can see it slightly better, can't you? But if I turn the lights off, there, you still won't see it because I've got. Okay, let's try turning the exposure on the camera up a bit. You can see it. Can you see that? No, really can't. There, you can definitely see it now. Right, so we're on capacitance. I'm measuring the capacity of the thing. Move that up there like that. Drum roll. Let's see what we've got. Should be 1000 nanofarads or 1 microfarad. There's your problem. Look, it's a quarter of a microfarad instead of 1 microfarad, so it's blown itself to bits inside. And I'm pretty certain if I put a new cap in, this thing will spring to life for a 99p dehumidifier. Should we open it up and have a look inside, see what's gone wrong with it? See why she's not playing ball. If I can find the cutters. Choppy going on here. Some of these are fiendishly strong, but if you abuse your cutters, actually these cutters aren't that easy to abuse. They are quite strong. I might just nip forward before I slice the end of my finger off. Come on, baby, we're going to unroll you. Keep on going, just keep pecking away at her. It's just like marriage, it keeps eating, just keep nibbling away at your sanity, in this case the cover of the capacitor, until you just say, oh, I've just got to give up. How much of a whipping can one enclosure take, eh? I would have used I've got some special low angle plastic cutting, large cutting cutters which I've loved, but I've lost them. Still, it's better to have loved than lost than never to have the cutters in the first place. I've snipped lots of things with that, but they're plastic shearing cutters, so this angle here across there, that angle is much smaller, so they slice through nicely. You know, this is a new thing for me. I've never cut a yellow one up before. I wonder if it's their corporate colours. Come on, baby. Don't want to necessarily damage the foil too much, but I am curious to see what we're going to find inside, aren't you? Because I opened up one on the previous video, if you watched it, and it was a complete anticlimax. It was just the bonding wire on the bonding file on the end of the capacitor had failed, causing a Bose not to work. Another, 30-cent component causing the whole bloody thing nearly to go in the bin, which is not what we want. This is not what that channel, or this channel, is all about. Oh shit. Eye protection on. There we go. We're getting down to the bare bones of her. Oh, well, that hit the light on the ceiling, that piece. Right. I don't want to use a scalpel because every time I do that I have a bloodbath. I tend to get over enthusiastic. Let's face it, lads, this is engineering porn for people that don't understand it, just aren't bloody interested. They leave some horrible comments saying, "Oh, it's so boring, didn't see anything explode, you take too long talking, and you could have explained it in 30 seconds. I said, well, it's probably, you probably only stood 30 seconds of it, because you're probably just too thick. Nothing wrong with being thick. The problem with being thick is when you don't realise you're thick. That's the problem. And you can't even comprehend how clever some people are. I've met some really clever bastards. I mean, they're just amazing. Made me feel stupid. Well, I'm pretty stupid, but do you know what I mean? If you can't appreciate things and get joy from cutting up a capacitor, then what can you do? I mean, it's not destructive. I don't have to go and pay thousands of pounds to go and shoot some tame lion just to make myself feel that my dick is a little bit bigger, like that American dentist. All I have to do is get a pair of cutters and have a workout. I don't have to go to the gym. I'll have a forearm like Popeye after this. I don't particularly want to snip that lead off, but I will if I have to. There we go, boys. Are you getting bored yet? You are, aren't you? Have a look out the window, see if you can see anything happening out there. Oh. Yeah, I say, one thing I would say about these capacitors, they've done a reasonable job of potting the bloody thing. Look at that. It's a potty capacitor. Oh, look, it's all oh, goodness me. Goodness gracious. There we go, look at this. Now we're getting into it. Now. Ooh. That was a good workout. It's morning, it's sunny outside with a few clouds floating by. There we go. One more little bit of blue, yellow, and we're in. League of Cruelty against capacitors will be on to me. So what's wrong with you, you thing? Should we just check to make sure we've still got 220 nanofarads? Yep, it hasn't even changed. Look at that. 226. This is good measurer. Don't like the display. And I don't like the continuity mode because it doesn't go beep as soon as the probes meet. So if you're whizzing down a row of pins on a microprocessor or something looking for a trace, it's no bloody good whatsoever. You have to go about, is it this one? Is it this one? Is it this one? With my old meter, it just goes, and it just goes beep as it goes past, and you sort of like, oh, it's that one. You know, it's just no good for doing reverse engineering, I'm afraid. Good meter otherwise, love it, but not for that. So this has got a yellow coating on the outside still, but that should come off with the... we don't need this wire anymore, do we? No, we don't. Right. We're nearly into the guts of her. This is the most unwrappiest one I've ever had to unwrap before. Look, and it's kind of... can you see that? It's got like bits and pieces on it. It's a live one here, boys. Oh, come on. Reveal your secrets. That must be an outer sort of special coating, mustn't it? That's like a protective outer thingamabob. What we want to see is the foil, don't we? Yes, we do. Come on. I've got a knife, I'm not afraid to use it. Oh, here we go. Getting into the business end. Now, why have you got only a quarter of the capacitor you're supposed to have? What's gone wrong? Did you have a difficult time at the factory? Look, it's so shiny, look at that. Isn't it lovely? Make a bit more Christmas tinsel. This is where I unwrap all this and find out the batteries in my meter have gone. I've just completely wasted everyone's time. That would be about par for the course. Oh, scalpel's what I want. The trouble is the wife's taken all the sharp objects off me. She says, I'm not going to do first aid on you again. You should know better at your age. There we go. Talking of which, she just come back from walking the dog, so her coffee should appear shortly. It looks nice and shiny, doesn't it? If I can get just to a single layer coming off, we should be able to unroll it. That's the shiniest tinsel you ever saw. Hello.
Get some more coffee.
Yes, please.
What are you making?
Not making, I'm destroying.
Ah, what are you destroying?
A capacitor. Me and the YouTube crew want to know why it's gone wrong. It's kind of an engineer porn thing going on here. Come on. So every time it gets across, it hits up against the side bit. Oh look, there you go. Can you see it? If you can, it's a bit shiny, isn't it? I'm going to put a piece of... Oh dear. This is what's... Can you see that? That's what's happened to this cap. I'm going to zoom in on that, then you have a look. So you might be able to... There might be some runes in there, mightn't there? So let's just go... Let's end that. Let's press... Yeah, so this is what a self-healing capacitor looks like. That's healed itself into almost oblivion. You can see the damage that's happened between the layers. You can see there's... that's why it's only 25% of what it's supposed to be. And it's like that all the way through. I've unrolled about a metre of this stuff and it's just the same. That's what's been happening. You can see the fractures in the areas that have pulled away. Yeah, so that's your problem. Is the damage that's been caused. So looking through my box of caps in my power supply repair rack, you can see I've got this one, which is a 1 microfarad 350 volt, which is way too big to fit on the board. There's the original one. It's a minnow in comparison volume wise to this. You can see this is obviously a much better capacitor. Yeah, so there's that one, and then there's this. I've got these 4 70 nanofarads, so it needs 2 of those, and that would be that big compared to that big, so it's quite big. So I'm going to have to take the fuse off the board and fit another fuse. There's a 20mm cartridge fuse in the way in a holder, so I take the fuse holder off. One of these fuses in there, and the fuse holders, like that. I take them off, and I should be able to, by putting these in parallel, because you put capacitors in parallel to double the value, the 2 capacitors, you put them together, connected in parallel, and put them in, and that should serve us quite well. So yeah, let's go back to doing that. Right, so here we go. In she goes. That'll go. Tweak that out. Solder that. Of course we've got to put a fuse in. Don't forget to put a fuse in. Okay. Right, we need a fuse, don't we? There's my caps in there. And we need a fuse. We need a 6 amp fuse. I'm going to use a 5 amp slow blow. That's plenty good enough. They'll sustain 10 amps for seconds at a time. These fuses, not quite the same one as the ones in there, but it's a lower rating. But it'll work just fine. And if it blows, I can just change it again. But I'm erring on the size of caution by putting a 5 amp in, which is a very commendable thing to do. I'm commending myself. There Here we go. Stretch her legs open, which is not the best thing to do without permission. There we are. Focus your focusing thing. I'm just going to put those across there and solder them both places, just so that we don't have all the current going through one solder joint. Right, what's the button this is going to work? Okay, so now we've got a 5 amp fuse instead of a 6, but it is a slow blow one, and we've got the 1 microfarad capacitance as it should be, although it's made from 2 capacitors. And let's just plug it in and see what DC voltage we're generating now. Power off, contacts on, brown trousers on, contact. Alright, so DC, come on. Guessing it's just to check. We can see if we've cured the problem by looking at what DC voltage, or well, actually what AC voltage, is not rectified there, is it? AC voltage we're getting on the you see that? You can just about see that display. Oh well. Right, so we're going between AC 0 volts, which would be the neutral line, and there we go, look, we've got 19 volts now, 20 volts, 15.3, that's it. Okay, so now, yeah, resistor's getting mildly warm, that's good, more power going through the system. Bear in mind that's AC, by the time that's rectified you'll have plenty of DC voltage to draw any relays. So that was your problem. It was a capacitor, and you know, you get some kit actually that will start playing up, you know, not working, or yeah, switch it off, switch it back on, it works, it warms up, it won't work. And often check that drop-in capacitor, because it is a very common cause and it's easily fixed, and it's so much better than going out and spending £300 on a new dehumidifier. So I'll put it back together and we'll just meet in the shed, in the workshop, after it's been reassembled, which is actually the exact opposite of the assembly procedure. Right. So we're back in the workshop. Got my repair controller down there. Got my unit here. I'm just going to put this back together now. Put the controller in, put the screws in, plug all the plugs back in. You've got a photograph of how the connections went. Blow it out with the airline. I'll come back to you when it's all assembled. Look, there's a schematic wiring diagram of the unit inside, which is quite nice. Nearly all air conditioners I've ever worked on for somebody have always had this diagram, so bear that in mind if you've got a wiring fault in this thing, because there is some useful information there. Well, she's reassembled and it works. It's producing water dripping into there. Very quiet unit actually. I'd say it's whisper quiet. It really is quite good. You can feel the vibration from the compressor going, and you can just about hear it, but all in all, very pleased for 99p plus a capacitor, don't you think? Anyway, so yeah, that concludes the repair. It's all done. If you want to see more of these, then just look down there for the subscribe button and press it, and also the notification bell so that you get a notification. And if you liked it, then leave me a like. Thank you very much. And if you've got one to fix, good luck with yours. If you've got any questions, I'll try and answer them and give advice, but they're very good units, and it's a shame they use such a shitty capacitor in the design. You'd almost think it was deliberate, wouldn't you?